All right, let's talk about a massive shift that's happening right now in the world of technology. A quiet revolution, really, that's completely changing how our favorite apps and websites get built. We're moving away from these giant, clunky systems to something way more agile, way more powerful. So let's dive in and see what this is all about. You ever use an app that just feels slow? Or a website that takes forever to get a new feature? Well, it's not just you. A lot of the huge single-piece applications that we rely on every day are really starting to hit a wall. They're struggling to keep up with the insane pace of today's data-driven world.
So here's our game plan. First, we're going to look at why these old-school monolithic apps are kind of breaking down. Then we'll jump into the microservice revolution, which sounds cool, and it is, but it also creates some new challenges, and we'll see how events are the key to solving them. And finally, we'll pull it all together into a modern data playbook.
Okay, so let's talk about this thing called the monolith. I want you to imagine you're trying to steer a massive cargo ship. Any little change you want to make, even just a tiny course correction, means you have to turn the entire vessel. That's a monolith. It's one giant, tightly coupled application where every single piece is connected. And you can probably guess, that's becoming a giant problem.
And this chart really just nails the issues. With a monolith, if you want to update one tiny feature, like change the color of a button, you have to redeploy the whole shebang, the entire application. And what if one part of your app gets a ton of traffic? Well, you can't just scale that one part, you have to scale everything. It is a massive, massive bottleneck for innovation.
So, how do we fix this mess? Well, this is where the microservice revolution comes in. The big idea is actually pretty simple, but it's incredibly powerful. Instead of building one giant, slow cargo ship, we're going to build a whole fleet of smaller, faster, independent boats. It's the classic divide and conquer strategy, just applied to software.
So what exactly is a microservice? Well, it's a small, standalone application that's designed to do one thing and do that one thing really, really well. It's laser-focused on a single business function, like handling user accounts or processing payments, and it talks to other services through really clear, well-defined channels.
To make this super concrete, think about an e-commerce site. Instead of one giant program running everything, you'd break it up. You'd have a separate service just for user logins, another one just for handling orders, a third one just for processing payments. You get the idea. Each one is its own little mini application running independently.
And the benefits here are just huge. Different teams can own their own services, which means they can develop and release new features way faster without stepping on each other's toes. You can also scale just one piece of the puzzle, like maybe just the payment service during a huge Black Friday sale, without touching anything else. And, my favorite part, if one service goes down, it's isolated. It won't bring the entire system crashing down with it. It's a total game changer for speed and resilience.
But, there's no silver bullet in technology. This new world isn't perfect. By breaking our one big, complicated problem into hundreds of smaller pieces, we've kind of just traded it for hundreds of smaller problems. We've created what's called a distributed system, and that brings a whole new kind of complexity to the table. All of a sudden, we've got to worry about all these services talking to each other over a network. What if the network is slow? And how do you keep data consistent when your order service and your inventory service have their own separate databases? And maybe the trickiest part, how on earth do you debug a problem when it might be jumping across 5 or 6 different services? And that brings us to the million-dollar question in this new world. When you've got a whole fleet of hundreds of independent services zipping around, how do you get them all to work together? How do you coordinate everything they do without creating a tangled, chaotic mess? Which, by the way, is exactly what we were trying to get away from in the first place. The answer lies in a completely different way of thinking about communication. Instead of services calling each other directly and waiting for a response, they communicate through something called events. This is the heart of what we call event-driven architecture, or EDA, and it all comes down to the power of asynchronous communication. Think of it like this. It's the difference between making a phone call, where you have to wait for an answer, and sending a text message. You just fire it off and move on. So in EDA, an event is just a record of something important that happened. An order was placed. A payment was received. Simple as that. So instead of the order service directly telling the inventory service, hey, go update your stock, it just shouts out to the whole system, hey everyone, an order was just placed. Then, any other service that cares about that can listen for that announcement and react. Here's how that actually works. First, our order service publishes that order placed event. It sends it to a central hub, which we call an event broker. Then, any service that needs to know about it, like our inventory service or our notification service, can just grab that event and react. The inventory service updates the stock count, and the notification service sends out a confirmation email. See how they don't need to know anything about the order service itself? They only care about the event. That is what loosely coupled is all about.
Now this loose coupling unlocks another superpower, polyglot persistence. It's a fancy term, but the idea is simple. Since each microservice is independent and manages its own data, it's free to choose the absolute best database for its specific job. No more one-size-fits-all. It is the ultimate right tool for the right job philosophy, but for your data.
And this just shows you how powerful that is. The order service needs really strict transactions, so it might use a classic relational database like PostgreSQL. But the inventory service, which deals with all sorts of flexible product data, would be perfect for a document database like MongoDB. And what about a recommendation engine? Well, that needs to understand complex relationships between things, so a graph database like Neo4j is the perfect choice. Each service gets to be perfectly optimized. It's fantastic.
Okay, so now we have our two key ingredients. We have our small, independent microservices, and we have this incredibly powerful, event-driven way for them to communicate. And when we combine these two things, we create something really, really special, a modern, reactive data platform.
This right here, this is the core formula. This is the secret sauce for building modern systems. Microservices give you the modular, scalable building blocks, and event-driven architecture gives you the real-time, loosely coupled nervous system that connects them all. Put them together, and you have a foundation for applications that can react to things the instant they happen.
And this isn't just theory, right? This is happening right now, powering some of the most innovative stuff out there. In finance, transaction events are being analyzed in milliseconds to detect fraud. In manufacturing, sensor data from machines can trigger maintenance alerts before a part even breaks. This architecture lets businesses react in real time.
So, we've covered the what and the why. Now let's bring it all home with the how. Let's talk about a clear playbook, some best practices, and the key things you really need to remember.
If you're actually looking to build this stuff, these are some of the key moves. First, you have to get the boundaries of your services right, and a technique called domain-driven design is perfect for that. Second, you want an API gateway. Think of it like a single, secure front door for all your services. And finally, you absolutely need special tools for this new, complex world. Things like circuit breakers can stop a failing service from causing a domino effect, and distributed tracing is absolutely essential for debugging because it lets you follow a single request as it jumps between all those different services.
So let's do one final quick recap to lock it all in. Microservices give us that modular, scalable structure. Event-driven architecture, or EDA, gives us the real-time, loosely coupled communication. The event bus itself, that's the central nervous system connecting everything. And polyglot persistence makes sure every single part of the system is using the absolute best tool for its unique job.
And that leaves us with one final big question to think about. This shift we've been talking about, from monoliths to microservices and events, it's not just a trend. It's a fundamental response to the demands of a real-time world. So, take a look at the systems you build or use every day and ask yourself, is your architecture built to react, to adapt, and to scale for the future? Or is it stuck in the past?